Well, hey everybody, how are we all doing? Robbie, Swamy, glad to see you again, you two. How you been keeping these last couple of weeks?
Best I can.
Absolutely.
Feel a little bit under the weather right now, but I'm doing my best. I'll see how this goes today.
Yeah, kind of ploughing on through, Robbie. Yeah, so right, we'll see how we get down. How things with you, Swamy? Why is Swamy on mute?
No audio.
Got no audio. See, typical, tech gremlins straight away.
Oh, actually, I muted myself because my younger one is roaming here like a drone. I don't want his noise. So last 2 weeks was pretty good, exploring a lot of concepts in and around the Kubernetes and Minikube, and how do you do the multi-container deployment in Minikube, and as well as the AKS cluster. It's pretty challenging and energizing, so I'm all charged up.
Yeah, no, absolutely. And it's good to be back. And hello to everybody watching us live on the live stream. Throw your questions in the chat. We'll try and pick them out as we go. We'll be monitoring that as we go through today's session. So I guess we'll start things off with a little bit of an introduction and really kind of, we're starting to get into the thick of it now with this series. We've been running, this is our 5th episode now. The link for the GitHub repo is scrolling down the screen below. You can get there. You can see what we covered in all the previous sessions. So please do go and have a look at those. Watch the other videos because, like I say, this solution, this e-commerce solution, microservices-based e-commerce solution, broken down into various microservices, and we've been deploying these using Docker Desktop. We've been deploying to an Azure Container Instance. For those small, those local and those small scale deployments to really try and understand some of these technologies and work out kind of between us why we might want to use one over the other. And certainly from my background, I'm not a software developer, so really I'm taking a look at what Robbie and Swamy, what you guys are up to from a development perspective, with how you're creating these microservices first and foremost, how you're testing and deploying locally, how you're pushing these up into more of these cloud-based services now. And today is certainly going to be an exciting sheep dip, I guess, into Azure Kubernetes services, because like I say, from my perspective, I've teetered around the edges with AKS and looked at it from an operations perspective to understand how do we get a cluster set up, why we might want to use that. But I guess, to try and, sort of set the scene as to what we're looking at today, and try and answer the question, why AKS? And I guess that's a really broad question that probably take us an hour to discuss and talk about all the pros and cons. But I guess from the perspective of what we've done up to now, using those local testing techniques, single or multi-containers, looking at hooking up a MongoDB container with an API microservices and testing that, we're really looking to scale and automate and offer that level of security and scalability, I guess, now with products like AKS. And I guess some of the questions. I guess some of the questions we're going to look to answer. Sorry, Robbie, do you want to chime in there?
I was just going to say, I think that speaks to it very, very much. I just wanted to reiterate that kind of pitch in that regard. I think that containerization is largely meant to help allow teams to provide guarantees, or to provide standards of service for high availability and scalability, and also disaster recovery. These are things that the nature of deploying things in a containerized fashion lends itself to. So,
and I guess that's the purpose of what we're going to delve into now, because I think from my perspective, this is where we're starting to get to the thick of it. I mean, it's great, and it's been brilliant insights working with you guys over the last few months now, building these series up, looking at how do developers build applications? How do they test them locally, in container? How do you test them using, Docker Desktop? And like I said earlier, last episode we looked at Azure Container Instance, for running those single container applications. And it's really great and interesting to see that we've got this plethora of kit bag of tools that we can use now. But today is about fundamentally AKS, and Minikube, looking at kind of multi-container deployments to these automated, scalable platforms now that we can really talk about security, compliance, and standards. And like you said, Robbie, those baselines of doing things correctly, I guess, for organizations, for enterprise-grade solutions. So, I mean, on that note, Swamy, I was just going to do a quick intro there. I've done my quick intro from an AKS perspective. Fundamentally, AKS is a managed services implementation of Kubernetes, hosted on the Azure platform. Obviously the hyperscaler platforms like AWS, Google have all got their own versions of this, but fundamentally Kubernetes is an open source platform that has been adopted and had a wrap put around it by the various vendors. Today we're going to look at the Azure platform, the AKS platform, but fundamentally it's a managed services, so we can just go and deploy a cluster. We can add some nodes to that cluster so that then we can go and overlay and deploy our microservices and our container-based solution onto that cluster. So, I mean, without further ado, Swamy, do you want to jump straight in there now, and maybe we'll talk about where does Minikube fit into this conversation?
Right. So, shall I share my screen real quick? Yeah. So here, if you see that, we are saying that we have started developing that bigger picture, which we have, and it's a long journey, I know, 1.5 years to 2 years to develop all these microservices. Since 4 sessions, we are here in this product's microservice. That's the first microservice we are building. We have basket, discount, and a lot of polyglot data store, and we have got aggregators and API gateways. We have client apps, server side, SPA, and the mobile. We have admin services, alerts and monitoring, SignalRs, and Kibana, Grafana, and a lot of things are going to come. Okay, that's the one. And another thing is we said cloud native. When you say cloud native, we are starting with some kind of development, and we said that microservices. It has got the backend. It has got its own data store. We are marrying these two. That's a microservice. And the second thing is we are coming and starting this. We are conquering this side of the world. How to containerize. Here also we did a lot of work on this containerization. Then the next thing will be we'll go ahead with this DevOps stuff, and then we'll come back to the continuous delivery. So that means we are purely the cloud native application development, developing the e-commerce solution. That's the big picture. Because we have limited time. In one session we have 1 hour, so we are discussing bits and pieces, but net whatever we are doing is this some goal. And coming back to this big picture, we are spending a lot of time We spoke about good features in .NET and Docker, and how do you deploy Docker Compose, Kestrel, IAS. We did lot. Then is Azure Container Instance and Docker multi-container inside the app service. Now we are moving towards this containerization, and again we'll come back to infrastructure as a code, and then GitHub Actions, pipelines, and securities and testing. Lot of things. This first microservice will take a lot of time, and then slowly to develop the other microservices. The time will not take 8 episodes, but it will take four to 5 episodes or less than that. We don't know at this point of time. That is the context which I'm setting, and I think you guys know is this is the repo where you guys can go and grab this, and want to play around, you guys can play around. And quickly, without wasting any second, uh, Jonny has already set up introduction to K8s and what and why of K8s. Like, I would like to add a little bit of colors or flavors to that, but the first point is, like, uh, Kubernetes is container runtime agnostic. That means it's not marrying itself to one kind of containerization. So is that Kubernetes, is that the only guy who can do this kind of job? No, there are other players in the game like Docker Swarm, DCOS. I've given the links. Please go grab it. And another thing is, it monitors, it it auto scales. And imagine you said that I want 2 instances of the API, and you go and manually kill one of the instance. It will take care of recreating it. We'll see that in action. Okay, if time permits today, if not in next session, definitely. So you can have full control having your production grade Kubernetes on your on-premise or on your private cloud, or you can have vendor specific Azure Kubernetes, or AWS Kubernetes, or Google Kubernetes. You can have your vendor specific. Now let's jump in to the hands-on. I just took the straight lift from the official documentation of K8s. This is the picture, and there are few, it supports few of the container runtime. So that means if you see this, what all the options do we have? So you can use the container D, you can use CRIO, you can use Docker engine. There are other options, they might come every now and then, but at least you are not married to one specific container runtime. We'll see that as of today, whatever is needed, we'll learn about that and we'll move further. So some of the terminologies which we will learn now. So something known as cluster. What does the cluster means? So we can have it. We can go through this one also here, but I will be switching between the presentation uh, uh, and also with this documentation left right. Please bear with me. Okay, so if you see this, the cluster architecture, let's see this in the cluster architecture. How does this nodes? Let's see that nodes. I just made a simplified version of the picture just so that we understand. So let's use the picture which I borrowed it from many different sources. So I'll flash that here. Okay. So first thing is, I should have put this cube control outside, but excluding this LO piece. If you see rest of these 3 nodes, like a master node and 2 worker nodes, that's the cluster. A collection of uh, a collection of nodes is called cluster. Okay, and the next important term what we need
Swami,
to know
those
is,
nodes are just
yeah,
potentially virtual machines, yeah? They're nothing more than a Linux
e-
or virtual machine.
Well,
exactly, exactly. Now
that's right.
if you come, go
That's
ahead, Robbie.
I was going to say they're running the nodes are virtual machines that can run pods, and the pods are wrappers around, or the deployment of multiple pods or wrappers around images such as Docker images that can be hosted inside of it. It's kind of an interesting thing whenever you're doing this locally, like on Minikube. You've got a hypervisor like HyperKit, where you've got Docker, which comes with its own, and it's running its own virtualization, and you're running it inside of that. And then inside of that, you've got these nodes that have their own virtual machine that are running these images.
Yeah, got you.
Right. So if you see that whatever we are speaking right now, I can real quick go back here and get into this. I'm keeping two different tabs. This is the node pool. When I go to this node pool, let me go here. Now that we have come this far, I want to touch upon this side and then go back to the documentation. I think we can spend 2 extra minutes on this one. So you can see this. This is the agent pool. Okay, I opened the agent pool in 2 different tabs, so that right now we have 2 nodes. So one out of this is a master node, one out of this is a worker node. So now you can see this. There is this VM scale set 001 I'm opening in the first tab, and the second virtual machine I'm opening in the second tab. Now the combination of these two is a cluster, Kubernetes cluster. So we'll do the practicals and we'll see that. Now you see this one is the 001 VM scale set, and one is 001 VM scale set. Right now you're seeing these two, the virtual machine 0 and the virtual machine 01. So we have 2 of these virtual machine. Okay, so these 2 are called cluster. Okay, and the next important point what we will focus is master and the worker node. That's very important piece. So who is master, who is worker node? So the master node will run only the system pods. It's also called as a control plane. We'll come and discuss in length afterwards, but as of today, understand that master node doesn't run any of the applications.
Swamy,
So generally,
I've got a quick question about that. So my understanding of AKS from a master and a worker node is that the master node is abstracted away. It's the managed service, the bit that we don't see. We just ask Azure to spin us up a cluster. My understanding is that Azure takes care of that master node. Am I right? And then you're just creating the worker nodes underneath that. They're the nodes that we can see through the portal. Am I right in thinking that?
Exactly. So we will see that. That's pretty good point. So if we come and see that current workloads. So if I see the current workloads here, and in this workloads, we are seeing this workload is hosting one of the instance of our API. You see this eShop products API, and that's in 001 machine. And if you come to the 001 machine, you see that that is hosting the MongoDB as well as the products API. So that means there is someone who's sitting on the other side who is the master node, and these 2 are the worker nodes, because the customer application is getting deployed here. So one instance of our eShop products API is in 0 machine, and another instance of API as well as the MongoDB is in 01 machine. So now we understood that there is some guy who maintains all these things, and these are the worker nodes where we have our application. Now the another term which we will go through is the namespace. Namespace is something like a organization. We say it's something like to organize or to wrap under this namespace. Okay, under this namespace I'm having these many pods, and under other namespace I can have these many pods or services or deployment, just to group it up. Okay, and another thing is pod. Now pod is one or more container, and it has got a volume. It can have a volume, and there is one IP. I'm calling it as shared IP, because if a pod has got single container, we can go and use the same IP and go hit that particular container. Imagine a scenario where you have a pod with multiple containers. In that case, what will happen is all these containers will use the same shared IP. Okay, and in our scenario, the microservice which we developed, where we have the API as well as the data store, the MongoDB, those 2 are not getting into the same pod. Those 2 are not getting into the same pod. That's very, very important piece which we need to understand, because that is a separate pod. Let's see that. Let's come back to this one. Why? We will speak about that one also. You see that MongoDB is one pod, the products API instance one is another pod, and the products API instance 2 is another pod. Because if we marry the API and MongoDB into one pod, in this scenario, if I want two instances of the API, and we married both API and MongoDB into one pod, that means if I scale into two pods, even though I don't want the second instance of the MongoDB, that will get spun. So in these kind of scenarios, it makes sense to put a piece and call it a container that will be helpful if you want to scale or shrink. You want to expand and shrink, that helps. If you marry two people and put it there, that means they both will expand, even though that's a ripple effect, even though you don't want, but that gets expanded. So coming back to the glossaries or the foundation pieces, like you have service, we see that here is a service with which you will be able to speak to the pods. You can see that that is the internal. We are not exposing to the load balancer, but here is the one we are exposing as part of the load balancer. And the next important term is deployment, is where you go and deploy the pods and other things. We'll see in YAML file, but as of now, the replica set. Now you can see that the replica set is we have two replicas. That means if I come into this workload and if I come to the pods, I'm taking some extra risk to dismantle it. I don't know whether it's going. I'm deleting it. Okay, I'm deleting one of the pod. I said that confirm. I'm deleting this. There are two pods for the API. Okay, so now we are seeing
because it's no longer available, right?
see this. I deleted, and now Kubernetes is taking care of that. It monitors, it ensures that the replica set, it should have two replica sets, and it is recreating the other one.
So
Till then,
specified in the YAML for that deployment that there are two replicas that should be running.
yes, I just put it in the two replicas because I just want to show the flavor that how do you work with single instance Minikube, and how do you work with Azure multi node cluster. Okay, that's one thing. And the kubectl, this kube control, apologize for short circuit.
kubectl, kubectl.
Yeah, how do you pronounce that? That's a big thing. Yeah, do we need a poll on that? How do you pronounce it?
I heard kubectl a lot, and even I love that kube control, but I heard kubectl. Okay, so I don't want a massive fight here on this pronunciation. So now let's come back to jokes apart. Let's come back to this session. I'm sorry. So what options do we have if you want to play with a single node cluster? So if you come and see that if you want to play with the single node cluster, you have multiple options. So you can use kind. This is the recent one. I didn't get a chance to play, but we have Minikube and we have kubeadmin. So you have multiple options. You can use Docker Desktop, you can use Minikube, you can use kubeadmin, and the kind, which is the new one. So let me switch back here and show that. So if you see the Docker Desktop, by default, you can enable the Kubernetes in the Docker Desktop. So that means this is one of the options. So to play around with the single node cluster. Now, the other option is Minikube. So you need to install the Minikube, which Robbie will be speaking on that. Then there is the context. Now I have 3 context. So whatever the commands I execute, currently this is selected, so it goes and hits the Minikube. So I can switch the context to the Docker Desktop, or I can switch to the AKS, which is this cluster. Okay, so if you want
Swamy,
to play around,
sorry to trip in. We just had one quick question before you go off, run down there. But Sava has just asked about the difference. What is the difference between the cluster IP, the node pools, and the load balancer? I don't know if you want to quickly touch on that for a minute.
Yes,
before we go off into Minikube quickly.
What is his name?
So it's Sava in the chat has just asked that what the differences are between cluster IP
server
load
Agar.
pools and load balancers. Yeah.
Looks like I read this guy's mind. I kept it comes to the cluster. You can see that the supports other workloads within the cluster, and the other one is node port here. So these are different nodes are there. So this is
Swamy,
for a specific.
what are you indicating on the screen when you're talking about this? It looks to me like I'm just seeing the web page. Dude. But you're
Which
talking
one?
about making changes. Oh, I saw it scroll. Oh, okay.
Okay, this is the one, and this is the load balance one. So the load balance, it goes and hits different nodes, and your pods are inside the uh, inside the node. So you can see that you can create the port mapping.
We're losing you, I think, Swamy, every now and again. Yeah, we've lost Swamy there. We'll
Okay.
break out. I'm sure he'll join
What
back
if
in
I
a
ask
second.
him where that was, because it's not actually on the page, the current session page on EU service products.
Yeah, well, I think I think the general, I'm not too sure which page that was, but I think the general theme is that the IPs that are attached to either cluster IP. My understanding is that nodes and pods can use that, but typically in production systems you wouldn't necessarily do that. You'd assign a load balancer or use the node IP itself.
That's right. So as I understand it, there are services that provide this. So you can attach to your pod, you can attach something that has an external IP, and then you can, and by assigning it to that role, then every time that pod comes up, being initiated as a new replica or something, not only will it have its internal IP, but it'll have a mapping for that IP endport that was described. Another one is an external IP, and obviously you can run another service for a load balancer.
And he's back, as if by magic. He's just wound up his put another 50p in the broadband connection.
Actually, there was a my 5G connection got dropped. And,
no worries. Do you want to pick up from where you were?
Am I back now? Am I back?
You're intermittent. I think you've got internet issues by the looks of it, Swamy. We'll keep going.
You know what? If you don't mind, Swamy, while we're
am I back now?
Yes.
See if you're back. Are you back?
Okay, thank God.
Yeah.
So that was the thing. You can see that to simplify the network configuration,
Load balancer.
we have creates an internal IP address to use within the AKS cluster. That's the cluster IP. And the node port is, we have seen that creates a mapping on the underlying node that allows the application to be accessed directly with the node IP address. And this is the load balancer. There might be slight disturbances, my younger one. Okay, so I have to surrender. So the other one is the load balancer, which gets hit the load balancer and it distributes the load. The exact thing which we are seeing right now, we are seeing right now here in our application, you are seeing that the virtual machine 0 is hosting one instance of our API, and the virtual machine 01 is hosting another instance of our API. So if I go to the services that has got one IP address, you can see server Raghava. These are the cluster IP which can be used internally, but this is the load balancer. We have an external IP. Now, if I come to this external IP, and if I go and hit it, so that guy is taking care to route this to either this API or this API. Both APIs exist in two different nodes. In node, this is zero machine, and this is 01 machine. We have a load balancer. The incoming traffic hits the load balancer. It takes care of to route it to the virtual machine 1 or virtual machine 2. If we see that the virtual machine 1 has got MongoDB and API, that means the request can come in here, which has got MongoDB and API, or the request can go here, which has got only API. So that's I think Sarva Raghava, we have answered your query. Please ping us back if you need additional discussion. We'll see that. Yeah.
Is that linked from our from that page? Is there a link from our page here to that documentation you were looking at?
No, I can put it. I already pasted it here.
Okay.
Uh,
I found that interesting. I wanted to take a
okay.
look. It was
You
nice.
can you can see that one. Okay. So another important topic which I want to cover is this the network. We'll come back to this one because we are running short of time. I'll go here, and to have the multi node K8s cluster, it's either AKS or EKS or GKE. Like you can have the Azure container instance or AWS container, Azure Kubernetes service or Elastic Kubernetes service or Google Kubernetes engine. You can have this vendor specific, or you can use this Kubespray or kubeadmin. So the same thing can be used for full control production grade, or so if you see that the full control production grade, you can the production environment you can use this kubeadmin. So these considerations which is specified here. Okay, that's one thing. So some of the things which we can quickly look into that. Sarvaraga, I've seen that you posted another question. We'll come back to that question. We'll have a any time which is remaining. We'll go ahead and we'll have the discussion on your queries. Okay, please park it for some time. If you are not able to answer, we'll definitely get back to you after that. I saw your second question, but I have things to cover, so I'm just running. But even if I'm not able to answer, I'll definitely get back to you by next meet, or give me your Twitter ID. I'll get back to you on that one. Okay. So when you do this, right now the context is Minikube. I can do the kubectl cluster info. So it shows that the Kubernetes control pane is this one, and the core DNS. These are the things which we will come back. Today is hello world of Kubernetes. Today is the first day when we are discussing about this, but we'll slowly come back to that one. So another thing what we can do.
Before you jump into the kubectl and the kube control there, if I can just take a minute to just describe like a contextual detail, because I had prepared a little bit to discuss how to install Minikube. So I just wanted to describe the separation. Like you had kube control on your document there on the image, but it wasn't actually part of. It didn't even look like it was really part of that group of different nodes, right? But you were indicating that it's not really part of the cluster, and I think it's important just now to tie those pieces together and describe where different things fall. In a work environment, you would have one or more, likely more master nodes, and the reason you would have more than one master node, particularly a great reason, is just for fallback and redundancy. You want to make sure that you have zero downtime in this process, and you have one or more worker nodes with various pods installed inside of them in your deployment. They would all be orchestrated together, and that's what you would normally be working with. But that's a large and complicated process that can span across multiple machines. And sometimes you just want to test to see whether or not something will work on your own machine. And a tool like Minikube will make that possible. You can take Minikube and you can install it locally. You can run everything just on a single node, or you can run everything on multiple nodes in Minikube. However, you're going to be using kube control either way. Either if you're connected to Minikube or you're connected to a production environment, the tool, a common tool to interface with that, a command line tool, is kube control. You have other options too. You can use an API. There are sometimes UIs that you can use, but kube control is a great way. And what it's doing is it's connecting to the API service on the master node, and it's just passing those commands to the master node. The master node is then deploying them and applying them within its cluster.
Here on my picture, here on my screen,
yeah.
Robbie.
Yes, that's right.
Yeah.
That's kube control separate that's actually on your machine that's not part of the cluster, right?
I know
Just,
I made a mistake. Actually, I should have wrapped all these nodes inside a box and move this guy outside. My mistake. Apologize, guys. I'll take it on me.
no worries. But I see what you were showing there. It's the API. It's talking to the API service, right? So
Exactly. So here we, yeah.
go
Go
ahead.
ahead, Robbie. Okay. So here we see when we run this kubectl get nodes, it gets these nodes. There is a surprise. Just hold on for a minute. So when you do namespace, it gives all these different namespace. And let's see that uh, when you do get pods, let's see this without giving the namespaces. So when you do kubectl get pods, that gives the pods which runs in the default namespace. Now, as we mentioned that the kube system runs all these HCD, API server, control manager, proxy, scheduler, whatever it is, it's all the system under the system cube namespace. Robbie will be showing that. Uh, Robbie will be showing the dashboard of that, but I would like to stop here. So the thing is that like kubectl creates it. The only thing is once it creates, if you re-execute it, it throws an exception. Better to use apply. You apply this. I will show you. Robbie will show this once is doing it, and this will go ahead and apply it. You can execute it any number of times. If at all there is change, it applies it. If not, it doesn't apply. So we'll see that. I just want to real quick take 1 minute time to show that one item. Like if you see that cube control, apply -f, deploy, and eShop, and this is the one. It is already there. We already have a deployment. See this? It says that, okay, from the deployment file, it's seeing that what items it has to deploy. It says that unchanged, 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 unchanged. If I change something in this YAML file and then hit it, then it gives it will update it. But as of now, there is no change between what is the state and what is the desired state. Both are matching it. Robbie, so
Okay, I'm
can
going
you
to go
run?
ahead. Yeah, I'm going to set up my screen share here. And
Sure.
you guys are seeing my screen, I hope.
Yes, sir. We
Okay,
are.
great.
Yeah,
So now I got
I'm
the
gonna have to. I'm
control.
gonna have to add you in 1 second, Robbie. I'll just
Okay.
get that over there now. But
Sure.
go on, you carry on. It'll only take me 2 seconds now, and I'll flick over to your desktop then. Go for it.
All right. So I wanted to just go through. I actually prepared things before this documentation was entirely prepared. So I'll be going through this with you guys. But first, I just want to wrap up a couple of pieces that people might want. If you're on a Mac, you probably have a very easy installation. You can just do a brew update and a brew install Minikube. That's assuming that you've already got Docker running. If you don't have Docker running, you can install HyperKit. I've got it misspelled here, but it's HyperKit is the hypervisor that you can get for free through Brew, like that. And then whenever you run it, instead of just running Minikube start, you would run Minikube start with VM driver HyperKit. You can do it with driver equals Docker otherwise. Or I think actually it will run, if I just do, it's probably already running right now. If I do it without it, I think it will default to the system.
Robbie,
default
we're not
version.
seeing your. Are you in a terminal? Because I don't think we're seeing your terminal again.
Oh, or am I only sharing a
Yeah,
window?
so we can only see your the Git page, GitHub page.
The
Let me
VS Code. We are seeing the VS Code.
Oh no, well no, Swamy, you're seeing it through. Right, yeah, I think we can see it there now. Go on. Do you want to share? There we go. Let me.
Yep. My bad.
Bear with. Hold the line, caller. We should be back in business.
All right. Let me know when you guys can see.
There we are. That's better. There we go.
All right. I apologize.
Drum-
I jump that sometimes.
Drum
This
rolls,
is-
please.
You're right.
Drum rolls, please.
This is it. Brew install Minikube. Now it's already installed on my machine. So if I do that, it's not going to do the same thing for me that it will do for you. But this the homebrew system is a great way to set up software like this, like Minikube, on your Mac. Very, very quick and simple. If you haven't gotten homebrew set up, that's one additional command you can go and search for. I think it's homebrew sh.
I use Chocolatey on a Windows PC, Chocolatey, and we've just had Winget as well for Windows PCs for these package managers. But yeah, there seem to be a lot of package managers flying about now. It's an influx.
Yeah, that's for sure. Let me just find, there it is. All right, and then I've got this document in Markdown. So if you, like I was saying, if you have Docker already installed, then these two commands are all you need. You just need to make sure you get Minikube. If you don't have Docker already installed, and for whatever reason, maybe you're just following along, but you don't really want to build our project and demo or the pieces of our project, you just want to use this on your own, you might brew install HyperKit before doing the Minikube, and then you'll be able to run Minikube directly on HyperKit. The other part I was saying is that I think I saw Swamy's demonstration show Minikube start -- driver equals Docker, and at least on the Mac, I have noticed that it will, whenever you run Minikube start without it, it will automatically go to, by default, to Docker if you've got Docker set up. At the end of that process, you'll see that kube control will modify, I think, your kube config such that kube control is connected to Minikube. So now all your kube control commands will actually show you what's running. Like if I do cluster info here, it'll show me information relative to my Minikube installation. So let's take a look at get nodes. So by default, you're just going to see Minikube. Whenever you set up your own node, whenever you have your application installed here through a deployment, you will then notice that separately. Also the status. The other thing is the roles. You see the role here, it says control plane. It won't say control plane whenever you're running your own application. If you look at old documentation, you might see that it says master instead of control plane. It was just like a name change that occurred. The status also might be something that's different. Like you might see numbers in here. If you see like 0/1, that means that it's there, but it's not actually currently running. So I'm actually kind of curious. Swamy, what's namespaces?
I was on mute. My younger one is here. So the namespace is like you group it, like set of containers. If you go and pull up the dashboard, in the dashboard you see that whatever the default view it shows. Could you please start this Minikube dashboard and open the dashboard where you see that the set of pods. I'm taking the example of pods. If you by default, if you see the pods, you see the drop down on the top band, horizontal band. Besides Kubernetes, there is a drop down top. Yeah. Expand it and change that to cube system or something. Yeah, now you see this, lot of things will pop up now. So all these pods grouping under a namespace, like how you do like a package or a namespace in C#, you group all these things in under one namespace.
Okay. All right. So here, let me leave that running since I started it without doing it. You know what I can do? Instead of opening a new tab, I'll just put it in the background. Okay, there. Now I can keep using it. This one you wanted to show me. So this shows me, these are, I bet you, the same ones we were just looking at. They are. Yeah, so you have a command line version of the same thing with kube control, get cubes in the namespace cube system. And then I see core DNS, etc, various cubes, and storage provisioner. And here I see core DNS, etc, various cubes, and storage provisioner. So the same data that you're seeing here, just in a less graphical form. They're both connecting to the same backend to furnish this data. All right, now actually, before I run this, I actually have to go to that directory, and that's going to be in my source code, source repository, which is actually in public. I think it's, oh yeah, eShop. Oh. There.
Are you stuck somewhere?
No, I was just trying to find the directory because you have this set from / and I wasn't in / yet, so I had to go to there.
Okay.
I should now see deploy, and I do see deploy. So now I should be able to run this. Before I run this, the first thing I want to do actually is look at it, because I don't like running something without looking at it. So just natural curiosity on my part.
Okay.
Yes, it's a YAML file, and it looks like it didn't open because they're backslashes. That makes sense. Yeah, let me cancel that. All right. See, it was a good thing for me to check because it, in fact, was wrong. For a Mac, I got to invert these guys. There we go. And now I can see that's it. A nice handy YAML file. We're declaring services, and under our services, we have an image that'll go into a pod. Why isn't this deployment? Well, anyway, I don't want to get into it. I don't know what's going on here. The service pod product DV, and then here's the API server, which will connect back to products DV.
I mean, it's probably wise, Robbie, to tell people watching this now that if they want to know how these two containers have been pulled together, to go and check the previous episodes of this series, because we've talked through all of this configuration up to now. So this hasn't just miraculously appeared from somewhere for this episode. It's been talked about on previous episodes. So do go and check back if you want to.
The one thing I will say is that we talked about volumes from the perspective of Docker, but in Kubernetes, it has a slightly different meaning in that the volume will be attached by Kubernetes to the virtual instance running your pods. So if you declare this volume, then this volume will be available. It basically means the same thing, but it's the Kubernetes version of it, right? So let's see now. kubectl create -f, and I'll just do that to get the same API version not set. That's interesting. It's because you have version instead of API version. I did an update today right before the episode, and I'm wondering if that's causing the issue. Let's try that again. Oh no, it's my issue. These false. Object kind is missing. Swamy.
Shall I
do
that?
Maybe if
thank you.
The create and apply and delete, because I'm having a little bit of trouble doing it live.
Yep, no problem, sir. I will. Let me share my screen. Is my screen visible?
Not yet. Let's get it back in there.
Now?
Yeah, 2 seconds. You carry on, Sean. We will be there now.
Oh, okay. So let me come back over here. So at this point of time, let me first delete this one. When I do delete, you guys can see these things will get vanish. Whatever it has deployed. Now we can do is kube control get pod or kube control get service or kube control get deployments. So there's nothing, and we wiped it off. Now what we are doing is, at this point of time, guys, you see this, there's nothing. I do that kube control, apply -F, and deploy eShop. I'm doing this K8s. So in this K8s, we are having the one deployment that's a MongoDB and its corresponding service. We have another deployment, products API, and one service. We have one secret to store the MongoDB connection string. We will get into the nitty-gritties and deep into the weeds of the YAML templates. But today is the first day of our life we are spending in Kubernetes. So we'll take a 30,000 foot view and we'll move forward just to be in the interest of time. But we'll definitely come back and we will we will create our own configuration files from scratch. But as of today, let's see this. So now we have this here. So you can see this. It has got its own IP. Now this is the right time for me to switch back to speak about the containers thing. You can see this. There are two types of networks, whether it is a KubeNet or Azure Container Networking Interface. Okay, so if you see that, if you take this KubeNet, so the nodes receives the IP from Azure Virtual Network Subnet. And if you take this Azure Container Networking Interface, okay, that's advanced networking. So you can see that each node configured to a maximum nodes with support. So there we might run out of IPs here. Okay, without, if you don't plan it properly, there is a chance that we might run out of the IP. So you guys can get into this. That same thing which we can see over here. If we come into this one, when we go to this section of the workloads and get into the pods, and you can see that each of this pod, the MongoDB has got one IP, and the eShop products IP has got another IP, and the second instance has got another IP. See the difference? This instance is alive since past four hours, and this is the one which we deleted just to show that Kubernetes automatically ensures that the replica set matches. Back to you, Robbie. I'm sorry.
I was just going to ask about the replicas. In the case of replicas, they reserve. Is that the reason why you could run out of IP addresses? Is because of replicas?
Oh, no, because you need to plan it properly. You can see this. It's not because of the replicas. It's because of the number of IPs which you plan it. Okay, the number of IPs which you plan it. You can see this here. You can specify that. Okay, I can have these many IPs in the Azure subnets, and it takes it from that subnet. Okay, in one of the things is you can see this in the KubeNet. You have the maximum of 400 nodes per cluster, and you have to plan it properly. That means at least whatever I learned it, I will show here. So you can see this one here. We are saying that the pod IPs, that's 16 bits. So those many pods can come in, and the services that can take IPs from here. See, the type is KubeNet. That means this type of network model we are using at this point of time. So we have 400 nodes, but here in this subnets, it's getting it from 65,000, I think so, isn't it? The 16-bit is the first 2 bits has been masked, so remaining. So 65,000, I think these IP addresses can go there. Okay, so let's quickly come back to our demo. So we deployed it. Now that we have deployed, we spoke about this IP, and we can do deep dive into the weeds. You can describe it, and that describes it here. You can, as of now, I'll just touch it. I'll not get into the deep because we are running short of the time. I need to show the AKS also, but you can see that what is the container ID image, what is the port, host port. You have a lot of things. You can get into deep into the weeds, and you can see that how it got scheduled, what image it pulled it. It pulled it from my Vishipilot image, and everything. You can get it. Now, how do I access? Now, this is I think our he already answered it to Sarva. Toby, you already answered. So Sarvan, you're seeing now. So now that what is happening is we need to speak about a couple of things. I will run kube control get svc. So when I run kube control get svc, you see that our products API is a load balancer, and it have the cluster IP which can be accessed internally. It cannot be accessed externally. So there is no external IP. So does that mean that we are stuck? No, we are not stuck. We need to do a port mapping. So that's what we are doing. We are doing a port forwarding, and I'm saying that map port 8090 to port 80. So that's where it did it. So now I come back to my Postman collection. I have 8 environments: Azure Container Instance, Azure Kubernetes, multi Docker Container and App Service, local Docker Compose, IIS Express, local K8s, Kestrel. So with this 8 environments, all I need to is switch between the environments, and I have a single collection. Now switched it. Now come back to this get products, and you see that it is pointing to 127.0.0 8090. So when I go and hit this, I made a first hit. Now you can see that it did that. And what we can do is right mouse click on that and get the logs and follow the logs and click on that. Now you see that it hit this, it got the products, and it spit it outside. Okay. So is that the one mechanism how I can access the API? No, there is other mechanism also. Why should I do that? So why should I do the port mapping? We'll come back and we'll see that. That's already there in this documentation. Quickly, let me come back over here. So you can see that. So when I run this Minikube status, when I run this Minikube status, it gives me some information. It says that, okay, I'm giving you the status, but you can also get this Minikube status by this command. So that means the Minikube, whatever the single cluster of Minikube, is part of Docker. It clearly is, we are seeing it. Docker container inspect Minikube. Okay, that's getting the status. Oh, I'm sorry, I did forgot to have another flower bracket. So that gives the status. Now let's quickly switch back here. This is the one. Now I can do an exec into that. Now I'm doing an interactive session. I say that host name. There you go. You're seeing that. I do Docker ps -grep products. That our eShop products is there. So that means literally now we are in the single cluster of this Minikube. That's one way to go. Another way to get into that Minikube is, let me stop this. Come on. Okay. So other way to do is Minikube SSH. I can do a Minikube SSH that takes me inside that cluster, and you can see that when I do a host name, I'm inside the Minikube cluster. Now, technically, I can do all these things which I was doing previously. So, is that the only way we will access? We need to do a port forwarding so that it goes and maps it to the maps it to that pod. So now, let me do the kube control get svc get service. You see that this is the 80, which we said that the host port 80 map it to this 80, which we were able to hit it. Even though it's a load balancer, it doesn't have the external IP. Toby already told that we need to do a port forwarding so that we'll be able to reach it. That's what we did it. Now there is another way we can do is Minikube tunnel. When we do a Minikube tunnel, you observe that. What happened? Oh, I think I need to write, Jonny, I think that's our next task. We need to write Minikube. It's not Minikube, right? Okay, so now I'm doing Minikube tunnel. So now what it does is like a VPN tunnel. It does a tunneling. So it says that now starting the tunnel to the eShop services. Okay, keep this session alive and come back to another session and execute the same thing here, like kube control get svc. Now you see that there is a public IP. Wow. So what we can do is copy this public IP. So that means this itself, it's directly tunneling into that. Okay. Now I'm going in here and I'm saying that 127 slash API slash V1 slash products. There you go. Boom. So now what did we do is we did go and hit this, even though it's a load balancer, we are inside the Minikube. We go and hit this through the tunneling. Okay, that's one concept. Now the other concept what we would like, I think that's the final one. We'll take a few minutes and then we can go on a Q&A. Stop, guys, please. Okay, it has stopped. Now let me come back to here, and I'm saying rightmost click on that, set the current context. Now whatever the kubectl commands which I'm executing, that is getting executed against the AKS. Now I do kube control get pods. Now, what are the pods which you're seeing, that MongoDB and two instances of the products? Now, one is like 3.5 hours or 4 hours, and one is 38 minutes ago. That means we are hitting that guy. Now, we can use the same Postman collection. That's the advantage. Robbie and Jonny, you guys can pitch in on this piece. Now, see this, I don't need to do anything. I have one Postman collection. All I need to do is, instead of the local eShop, I go and switch my environment and hit it. Now you can see that that's going to 20.107.14.207. We are going and hitting this one. Okay, so it's good that to have a Postman collection. You can have n number of environments. You don't need to change anything. Authorization is there, you can fix it. But apart from that, having one good Postman collection will help you test in n different environments. So
was that on the K8s version? Notice you have different versions for different deployment types in your Postman.
Oh yes, the one is the Azure container instance. Other one is Azure Kubernetes service. Another one is, which we discussed in the session 2 and 3, the multi-container Docker instance in app service. This is Docker local, Docker compose local, IIS Express local, K8s local, and Kestrel local. K8s is I'm doing a Minikube with port forwarding, and I didn't include this tunneling piece. So wanted. I mean, it was fun doing this session seriously. And now that we have covered to a decent extent, let me come back to this picture. We started with this microservice, and slowly we are coming to the another piece of this cloud native, the microservice. It has got the API and it has got its own data store. Now we started working on these containers. Now we are moving more towards the enterprise grade AKS. We are using that, and slowly now we need to create infrastructure. How do we create? So the next session will be, we will be introducing a couple of new features. I'll take, like, instead of using the class, we'll use the record set. When the object doesn't need to change, let's make it a non-changeable, and we'll use a unified response using the response DTO instead of sending true or false or enumeration collection of objects or a single object. Doing all these things, we'll have a unified object, and Robbie will touch upon that. And purely we'll focus on the infrastructure as a code. How do you create resources in Azure using the PowerShell, or using ARM templates, or using Azure CLI, using Terraform, and we'll focus more on that. And then we'll go towards the GitHub Actions, pipelines, and other things. Like totally, it should be like purely like completely cloud native. Okay, back to you, Jonny.
I think that we did a good job of introducing Kubernetes there, covering a lot of ground on that.
Yeah, I mean, seriously, this was the tip of the iceberg. Like, there are tons and tons of things.
Yeah, it's a big it's a big piece to get your head wrapped around. It's a complicated set of components there, where you've got deployments on top of pods, on top of container images, and then all of those side of clusters when you have services. So yeah, there are some pieces that I think, even though we've covered it, everybody who is following this in any serious way would also benefit from going back over this themselves and taking a look at it on their own.
Yeah, as we mentioned, like today is the first day of our life we are spending in Kubernetes, maybe the Minikube or AKS or whatever it is. Now there are a lot of things to explore. Now this is whatever we are doing manually. We need to do it through scripts. Then we need to come in through the build pipeline, release pipeline, push this images to the Docker or Azure container registries. And there will be release pipelines which will go grab these images and deploy it to this Kubernetes service. Before that, there should be Terraform, which creates these resources. That infrastructure has to be created. Then we need to go deploy. I mean, as we mentioned, it takes a lot of time for us to create our first completely create our first cloud native microservice. It's not that we do one piece and say that we dusted it off. No, we have a lot of things. We have API, we have data store, and we have local containers. Then we slowly moving towards AKS or the enterprise grade Kubernetes, and then we have infrastructure, the build pipeline, release pipeline, static code analysis, software composition analysis, the monitoring, alerts and monitoring. A lot of things are there. Let's spend a decent amount of time to create our first microservices as much as possible. Even if it is taking 10, 12 episodes, we are fine. But let's learn all the tips and tricks as much as possible. I'm not telling that we will be the experts, but let's stretch our wings and muscles as much as possible.
You can do a proof of concept for your own sort of project locally. So, and I think the TLDR to walk away from in this is that you can use Kubernetes, you can use container instances in Azure, and you can do development for that locally using tools like Minikube and Kube Control or the dashboard UE that we looked at today. Yeah, those are the landmarks that are important to note.
Please grab this. I'm again putting it for the benefit of others in this YouTube. Thanks, Robbie. Really appreciate. So if you see that here in this documentation, we mentioned that um, alternatives to Kubernetes, like DCOS or Docker Swan or Kubernetes, you guys can explore like vendor specific. You have AKS or the Amazon's Kubernetes or Google Kubernetes or others also, and single node clusters and runtime. You have many options. You have Docker, you have Containerd and CRIO. But if you see that AKS, it uses Containerd. That's what I observed it. And like single node cluster, we said Docker Desktop, Minikube, KubeAdmin, and multi-node cluster. You have vendor-specific AKS, Amazon, Google, and KubeSpray, KubeAdmin, lot of things. I mean, it's like a big ocean, as Toby also pointing it out. It's like a pretty big, massive topic. We can speak months together on this to get a hold of that.
Cool. Well, there we go, and we did it. Yeah, we're not that far off as well. As that was a great session again, Swamy and Robbie. I think hopefully we're helping everybody that's watching. Like Toby's pointing out there's certainly a mind shift that needs to happen here with a lot of people, and this is the point of this series, I guess, is that it's not just software developers that need to think this. It's obviously the operations side as well. When we get into that infrastructure as code piece about configuring and spinning up these clusters in Azure or any other cloud vendors platform, how do we manage them, how do we monitor them, how do we configure them and move forward and use them and maintain them in a production live system, effectively. So yeah, there's lots to talk about. So we'll call it there, I think, folks. So thank you, Robbie. Thank you, Swamy. A pleasure as always.
Happy holidays to people in America.
Absolutely.
Hey, happy Independence Day.
Couple of days. Yeah.
Robbie, I think 4th July, you have a long weekend.
Yep.
Enjoy.
No.
Yeah. Enjoy the long weekend and happy Independence Day too.
Absolutely. See you all in a couple of weeks' time. Bye for now.
Bye, guys.
Good night, folks.